things like misdiagnosis always happens with in-person care for doctors. But can you imagine those numbers and how they dramatically increase when we're just using things like 2D imaging or 2D slices of scans, rather than actually using 3D models to analyze anatomical structures or how the anatomy works in the body? This is where we often run into a little bit of trouble. I mean, one of the questions I always ask myself is, if our bodies are in 3D, if our biological structures are in 3D, then why are we still using 2D imaging to view things that 3D imaging should provide for? The good news is this. There are a lot of advancements being made in the medical field to provide for the lack of 3D imaging. There are a lot of 3D models that are being created and different 3D imaging techniques for CAT scans or MRIs. But here's the catch. All this has to be processed through the hospital first. And that requires a lot of expensive resources, doctors' times, when they could be focusing on other things. The more severe things, like their patient's diagnosis, or actually coming up with treatments or cures for the patient. So we need to start thinking a different way, a way that we can save these resources, but still provide the same 3D anatomical structures to view patient models with. Now, I have done, and I am currently doing a lot of research in the power of virtual reality and how that can help to provide doctors with 3D visualization or 3D anatomical structures at just putting on a VR headset and viewing an entirely different world. The thing with VR, though, is that it often requires a lot of equipment and resources that might not even be necessary when we're not completely immersing ourselves in a new reality. This is where the power of things like augmented reality comes in, and how we can just use our phones or use our devices to scan over our world and add virtual elements to them, even adding things like 3D models to save time so doctors don't have to go through this process of having these images processed by the hospital first. So to give you a good idea of what this virtual world would look like, I actually use a Sketchfab and Autodesk or AutoCAD software to create and deploy and build 3D models of MRIs and basically inject that or program that into an augmented reality software. So doctors can have these different scans and 3D models at their disposal, focusing on the things that they need to the most: patient consultation, connecting with their patients, and developing treatments for them. But I'm going to take you through the process of this entire thing. Let's start from the very, very beginning. How do we actually do this? I know, trust me, it sounds too good to be true. But the good news is that they're already working on stuff like this. There are already so many different medical applications that are meant for things like augmented reality or virtual reality, or building 3D models for anatomical structures. So this reality of just being able to scan over a patient or scan over a 2D scan and have a 3D model of it appear right in front of us is really not that far-fetched. But we have to break down the different steps in the process of being able to do that. And the first step is actually collecting patient data, seeing where we can find scans and find the information to be able to do this. So part one actually breaks down the data collection and what we need to be able to do something like this. There's no way to be able to jump into making 3D models if we don't actually have real records or scans or patients to talk to. In my lab, a lot of what we focus on is a progression of different cardiac diseases. But the problem is that we often use 2D models to be able to do that. So I started thinking in a different way. How can we use 3D models to do that? How can we fabricate these 3D anatomical structures just by scanning over a simple textbook, seeing the 2D image, and having the 3D version of that appear right in front of us? So before I decided to actually construct the 3D models, I took a good look at what my lab was doing and the different patient records, scans, and basically all the different information overall, so I can make a good judgment based on what the 3D version of that model would look like. Even taking a look at things like hearts, I would be able to visualize in my mind what a lesion on the heart or what a cardiac disease would look like, and be able to monitor the progression of that, building 3D models. So it's actually really cool to be able to build something of my own from the ground up and be able to see how different things like 3D visualization or augmented reality plays a huge role in that. So now let's go through the second process, the actual building, deploying, and constructing of the entire models. A lot of the technology we've adopted in the medical industry oftentimes comes from a place of wanting convenience or not using that many resources. I mean, why order so many expensive tests that cost thousands and thousands of dollars when you can just have a machine learning algorithm predict a medical disease or a disorder, right? In that same way, that's when we start to include artificial intelligence and things like augmented reality into discussion. So the third part to this is the actual augmented reality integration. If you think about it, a lot of the technology we've adopted in the medical industry often comes from a place of wanting convenience or saving a lot of resources, time, money. I mean, why order thousands of expensive tests when you could just have a machine learning algorithm predict a disease or a disorder? In that same way, why order so many different types of 3D imaging techniques when we can just have virtual elements or that same 3D model projected onto the screen or onto the device when you're scanning a patient or a 2D image of a scan. You can use this to have virtual features of the patient's anatomy right in front of them, just by scanning over the patient or even scanning over a 2D image of a scan and have that appear in a 3D model or meant for 3D visualization. One thing's for sure, augmented reality will completely change the progression of so many different types of ways that we diagnose diseases and basically consult in general. There are so many different technologies out there and applications that are going on in virtual reality, which is completely amazing. But when we're trying to save money and resources and trying to optimize for convenience, augmented reality does an amazing job at that. And we just start looking and opening up the possibilities of it, unlocking the value that our medical field provides for so many different things like 3D models and having direct access to them.